Hello students, welcome to the course on network theory. Till now we have studying the Y parameters. In this lecture we are going to discuss where the Y parameters are really used in the real world application, and we are going to solve some numericals on it. Until now we have studied Y parameters mathematically. We defined them using our short circuit conditions and express the current in terms of the voltages. But the real importance of Y parameters becomes clear only when we understand their practical applications. One of the most important areas where Y parameters are used in the power systems. So you can see here our transmission network is generally acts like a unknown two-port network, where there is an input port, the generator supplies the power, and at the output port, the power supplied by the generator has been consumed by the load. So here at the input side, we try to compute Y11, that is input impedance, which tries to determine how much current is drawn at bus 1 due to the apply of the same voltage. As a result, we try to find the bus power injection sensitivity, what is the load flow behavior, and what is the load voltage stability. And bringing to the output side, it is Y22 is the output admittance, which try to determine the current at this port due to its own voltage, that is load modeling, fault current, and reactive power. And in the middle is a transmission network. We generally assume it's a black box, how it is connected, and we try to compute Y21, and which tries to determine how much current at the port 2 is drawn due to the applied voltage at port 1. So we are trying to compute what is the power transfer, what is the line loading at the transmission line, and what is the inter-area coupling between different areas of the network. And we are having other kind of applications in a power system similar to your Z parameters. For example, in power system network consists of generator, transmission line, transformers, and loads that are interconnected over a vast geographical area. In the system, the engineer often need to study how the current flow and the voltage are specified at different buses, because Y parameter relates current directly to the voltages that are extremely converting for forming what is known as the nodal admittance, that is commonly known as Y bus matrix. Thus, this Y bus matrix is generally used for analyzing the load flow studies, fault analysis, stability analysis, and even the state estimation. Thus, Y parameters are a mathematical backbone of our modern power system. Another important application is the integrated circuits and transistor amplifier analysis. At high frequencies, transistors behave as often described using the admittance model, because current responds more directly to the applied voltage in small signal operation. Thus, we can say that by using the Y parameters, which help the engineers to determine what the input impedance, input admittance, output admittance, current gain characteristics, frequency response of the amplifier. So this makes the Y parameter particularly used for analog and RF design circuits. The Y parameters are widely used in microwave engineering and high frequency network modeling. At high frequencies, circuits generally exhibit different effects or distributed effects, and the current voltage relationship becomes very complex. Thus, your admittance based formulation tries to simplify the matching network and radio frequency filter waveguide components. And we have even the antenna field systems. Another major applications of the Y parameter is the network synthesis. In network synthesis, the engineer tries to design the circuit that produce a desired electrical response, such as a specific impedance or admittance or frequency characteristics. So, admittance functions are often easier to manipulate mathematically when designing the passive filters. Finally, the Y parameters are also used in the control system modeling, where electrical subsystems interact with mechanical or thermal systems. In such cases, admittance relationship between the system equations that are suitable for stability and dynamic analysis. So overall, Y parameters are especially powerful in systems where the voltages are treated as an independent variable and the currents are response that must be calculated. This makes a particularly important in power system computation and higher frequency circuit analysis. Now we shall solve some numerical problems. Let us consider this particular circuit. Given the following circuit, we need to determine the y parameters. What are the y parameters? It is y11, y12, y21 and y22. So there are different ways of doing or computing the y parameters. Let us solve these y parameters using our mesh analysis first. So we are having 3 meshes. So we are going to have 3 mesh equations. And this is, let us assume this is mesh 1, and let us assume the current flowing through this mesh is similar to one here, that is I1. Now let us assume the I2 mesh, this is the mesh current I2. I am flowing in a anti-clockwise direction, and let us assume we have another mesh current I3 flowing in a clockwise direction. Now we shall apply the mesh analysis. So when we apply our mesh analysis for mesh equation 1, we are going to get V1, we have a voltage rise from minus to plus. So whenever the current I1 flowing in this particular clockwise direction and I3 in this particular clockwise direction, we can see that there will be a voltage drop across this 8 ohm caused due to the current flowing through I1, and there will be a voltage drop across at least 20 ohm caused due to the current flowing due to the combination of I1 and I3. So we are going to have voltage rise of V1, and we are going to have a voltage drop of 8 I1 plus 20 into I1 minus I3. Here we assume that the considered mesh current I1 is greater than I2 and I3. So this is the equation we got here. So try to rearrange this equation. We get V1 equal to 20 plus 8, 28 I1 minus 20 I3. So let us assume this is equation 1. Now let us write equation 2, where we are going to have this I2 current flowing to this mesh equation mesh 2. We have again the voltage rise minus 2 plus, and we have a voltage drop across 20 caused due to the current flowing through the combination of I2 and I3. So my V2 is equal to 20 I2 plus 20 into I3. It's my second equation. My third equation here is there is no voltage rise in this particular mesh, so it is 0 and minus 20 I1, because the current flowing through this 20 ohm due to I1 is from top to bottom, whereas I3 is going from bottom to top. So it's a minus 20 I1 plus 20 I2 plus the current I3 is flowing to 10 ohm, 20 ohm and 20 ohm. So 20 plus 10, 30, 30 plus 20, 50. So it is 50 I3. So let us assume this is equation 3. And what we need to find? The y parameters. How my equations looks like for y parameters? It is I1 equal to y11 V1 plus y12 V2 and I2 equal to y21 V1 plus y22 V2. So if you observe these equations here, all the equations are in the terms of I1, V1, I2 and V2. So we have another term I3 in these particular 3 equations. So let us eliminate it first. So in order to do that, let us convert here. So it is 50 I3 is equal to 20 I1 minus 20 I2. So my I3 is equal to 2 by 5 I1 minus 2 by 5 I2. Let us suppose this is equation 4. Now what we try to do, we try to put equation 4 in 1. So what we are going to get? V1 is equal to 28 I1 minus 20 into 2 by 5 I1 minus 2 by 5 I2. So try to rearrange this equation. We get 28 I1 minus 5 and 4, 4 to the 8, 8 I1 and minus into minus plus 4, 4 to the 8 I2. So we get 20 I1 plus 8 I2. This is my V1. So let us say this equation is A. Similarly, what happens if we try to put this 4 into, now try to put equation 4 into, we get V2 is equal to 20 I2 plus 20 into 2 by 5 I1 minus 2 by 5 I2. Right? So if we try to multiply, we are going to get 5 and 5 4 ja. So 4 to the 8 is 8 I1. We are going to have 8 I1 and 4 minus 2. So minus into plus minus. So minus 8 I2. So we are going to get plus 12 I2. So this is my V2. Say this is equation B. So my V2 is equal to 8 I1 plus 20 I2 minus 8 I2. So we are going to have 12 I2. Let us write these two equations again. Say it is V1 equal to 20 I1 plus 8 I2, 20 I1 plus 8 I2 and V2 is equal to 8 I1 plus 12 I2. But what we require? We require I1 and I2 in terms of V1 and V2. But what we got? We got V1 and V2 in terms of I1 and I2. So let us rearrange these equations. So how do we rearrange? Try to observe what we are trying to do. Here we are having I1 in terms of V1 and V2. Here we are having I1 in terms of V1 and I2. So let us eliminate I2 from this using particular equation B. So as we assume this as A and B, so we can rewrite I2 as in this particular way. So 12 I2 equal to V2 minus 8 I1 and my I2 is equal to 1 by 12 V2 minus 2 by 3 I1. So let us substitute this equation C, put equation C in A, we get, we have C, observe here, we got V1 equal to 20 I1 plus 8 into 1 by 12 V2 minus 2 by 3 I1. So if you observe here, we got V1, V2 and I1. So let us again rearrange these equations. So V1 is equal to 20 I1 plus 1 by 3, so 2 by 3, V2 4 2 ja, 4 3 ja, so this one minus 16 by 3 I1. Okay, so take I1 as common. We are going to have V1 equal to 20 minus 16 by 3 I1 plus 2 by 3 V2. So V1 is equal to 60 minus 16, 44. So 44 by 3 I1 E plus 2 by 3 V2. So let us bring this V2 towards left. We get 44 by 3 I1 is equal to V1 minus 2 by 3 V2. So I1 is equal to 3 by 44 V1 minus 1 by 22 V2. So this is my first equation. So we can see that this 3 by 44 is my Y11 and minus 1 by 22 is my Y12. Now what we need to do? We need to substitute this I1 in this particular equation so that we are going to get I2. So let us solve that one. So my V2 is equal to 8 times of 3 by 44 V1, 3 by 44 V1 minus 1 by 22 V2 minus 1 by 22 V2 into plus 12A2 plus 12A2. So we require I2. So let us rearrange these equations first. So my V2 is equal to 24 by 44 V1 minus 8 or 16 by 44 V2 plus 12 I2. So let us rearrange these equations and try to bring V2 towards right, or we shall take this particular terms towards left. So we are going to have 12 I2 is equal to minus 24 by 44 V1 plus, let us take V2 common, so 1 plus 16 by 44 into V2. So my 12 I2 can be written as minus 24 by 44 V1 plus 44 plus 16, again 60 by 44 V2. So let us bring 12 to this side. So we are going to get I2 equal to minus 2 by 44 V1 plus 12 by 60. So it is 5 by 44 V2. So this is my another equation. So by comparing these equations, we get my y1 as 3 by 44, 3 by 44, and my y12 is as minus 1 by 22, and from here it is y21 as the same minus 1 by 22, and y22 as 5 by 44. So you can observe that my circuit is a reciprocal circuit. And why this is a reciprocal? Because there is an absence of our dependent sources. However, the circuit is not symmetrical circuit, because if you try to see here, we are having 20 and we have a 10, but we have 8 ohms between this particular node and this particular node, and there is no resistance. As a result, these two ports behave differently. Now let us see how we are going to solve the same numerical in a different way. Because if you see here, we are having a lot of equations. We are trying to put one equation in the other way. So it is little bit confusing, it may be difficult for few students. So let us see how can we solve the same problem in a different way. So if you observe here, we are having this particular network, and in this circuit we are able to find that we are going to have some chain network which forms due to the resistors 8 ohm, 10 ohm and 20 ohm, and we are going to have 10 ohm, 20 ohm and 20 ohm, which is a pi. Right? We can even consider this as a T network, 10, 0 and 20. However, as we are trying to do Y parameters, it is better to convert a T to the pi network. So we try to convert this T network, T circuit to a pi, and we are going to have one pi network parallel with 20. We can reduce it, and we shall see why we are going to convert in this particular way. So now let us start. So assume this is one node, node 1, and we have common node, and this is node 2, and this is node 3. So we are going to convert this particular T into a delta, or star into delta. So we are going to get in this particular way. So we are going to have this particular delta. Let us assume this is RA, RB and RC. So now let us compute first RA. So how can we compute RA? It is for the sum of the product of two resistors. So 8 into 10 plus 10 into 20 plus 20 into 8 divided by the opposite resistance. That is, the opposite resistance of our RA is 20. So it is divided by 20. So let us compute it. It is 80 plus 200 plus 160. So 160 plus 80, 240. 240 plus 200, 440. So it is 440 divided by 200. Or we can write 44 by 20. Okay. Now let us compute for RB. So RB also, the numerator will be the same. The product, sum of the product of two resistors, 8 into 10 plus 10 into 20 plus 20 into 8 divided by the opposite resistance. Where we have considered the RB here. So the opposite resistance is 10. So divided by 10. Sorry, here it is 80 plus 200 plus 20 divided by 20, not 100. So it is 20 and 44 by 2. So you are going to have 22. Now this becomes 440 divided by 10. So it is equal to 44. Similarly, RC can be calculated as 440 divided by opposite resistance, that is 8. So it is 220 by 4, or we can directly 110 by 2, or it can be written as 55. So this is 55 ohms, this is 44 ohms, and this is 20 ohms. So let us redraw this particular circuit. So how my circuit looks like now? So we have a circuit in this particular way, and we have another resistor, and we have another resistor, and we have 20 ohm resistor, and this is our port 2. So if you try to rearrange, this is my V1 plus minus, and this is my V2 plus minus, and this is I1, and the outgoing current I1, entering current I2, and the same current leaves at another terminal I2. So this is my 20 ohm, and this is my RA, that is 22, and we have RB over here. So RB is 44, and we have the 55 ohm resistor here. Now further continuing, we can see that my 55 and 20 ohms are connected in parallel. Okay. So we can convert this into a pi network. So, and we have a pi network over here, and the value of this resistance is 22 ohms, and this is 44 ohms, and this is this will be my, say, 55 into 20 divided by 75. So we can say that 5 4 ja, 5 15 ja, 5 3 ja, and 5 11 ja. So it is 44 by 3. So if you try to redraw the same circuit, converting this circuit into a pi network. So we have in this particular way, and we have here 44 by 3, we have here 22 ohms, and we have here 44 ohms. So let us consider a circuit, say, in this particular way. So let it be, this is by 1, and let it be by 2, and let it be by 3. So this is a pi circuit, and we are trying to find the y parameters. V1, this is V2 plus minus, here this is I2, and this is I1, and we are having I1 here, and we are leaving I2 current here. So I am trying to apply my nodal analysis. So if you see, my incoming current is I1, my outgoing current is Y1 into V1 minus V2, and plus Y2 into V1. So if you try to rearrange, we get I1 is equal to Y1 plus Y2 into V1 minus Y1 into V2. And if you try to apply our nodal equation, nodal analysis at node 2, we write I2 equal to Y1 into V2 minus V1 plus Y3 into V2. So if you try to rearrange, we get I2 equal to Y1 V2 minus Y1 V1 plus Y3 V2. Try to take V2 common here, we get I2 equal to minus Y1 V1 plus y1 plus y3 into v2. So if you observe here, this particular equation and this particular equation and compare with the standard form of y parameters, we can observe that my y11 is equal to y1 plus y2 and my y22 is nothing but y1 plus y3, whereas my y12 is equal to y21 is equal to minus of y1. Similarly, if you try to invert this one by circuit, the values of the resistance, we are going to have, say, this particular way. So this is v1 plus minus, this is v2 plus minus, so this is I1 and this is I2. I2 currently is here and I1 currently is here. Try to invert it, it is 1 by 22, this will be 1 by 44 and this will be 3 by 44. These all are in moles. Okay, so what will be my y11? Y11 will be equal to summation of these two, that is 1 by 22 plus 1 by 44, whereas y22 will be equal to 1 by 22 plus 3 by 44 and my y12 which is equal to y21 which will be equal to minus 1 by 22. So let us simplify this further. It is 22 and 1, so it will be 3 by 44 and it is 2 plus 3, it will be 5 by 44 and this is minus 1 by 22. So if you see our previous problems method, we got 3 by 44 and 5 by 44 for y11 and y22. Here we got 3 by 44 and 5 by 44 for y11 and y22, and for my y12 equal to y21 equal to minus 1 by 22, and this is y12 equal to y21 equal to minus 1 by 22. So it has been satisfied. So if you observe here, the number of equations we have in this very much lesser. So depending upon the circuit we have, we can make use of our network reduction technique and we can solve the numerical. And now we will be asking, can we have any other method to solve this, or can we apply our nodal analysis directly, as we have studied in the previous class, where we try to apply mesh analysis for Z parameters and nodal analysis for Y parameters. Can we apply our nodal analysis directly for this particular circuit? So let us see. Here we are having 3 nodes, or to be precise 4 nodes, and out of which 3 are non-reference nodes and 1 is a reference node. So this is my V1 and this will be my V2. There is no voltage drop here. The voltage at this particular node is equal to the voltage at this particular node. So V2. So let us assume this we have another node called V3. Now let us write the nodal equation by applying it. First the nodal node 3. So we can see that at here we are having V3 and we are having V2 over here and we are having V1 here. So if you try to apply here, the incoming current is I1 and the outgoing currents are V3 minus V2 divided by 10 plus V3 by 20. And what is the second equation we can write? My I2 is equal to V2 minus V3 divided by 10 plus V2 by 20. And if you observe here, we are having 4 variables, I1, I2, V1, V2, V2 and V3. Only 2 variables. But in equations, we require the V1 rather than V3. So how do we eliminate? So we can write my V3 as V1 minus 8 into I1. So we have V3 here, we are having V1, we have having a voltage drop of 8 I1. So if you try to substitute in this equation, we have I1 equal to, so V1 minus 8 I1 minus V2 divided by 10 plus V1 minus 8 I1 divided by 20. So if you try to rearrange these equations, we are having V1 by 10 plus V1 by 20 minus 8 by 10 I1 minus 8 by 20 I1 minus V2. Okay. Let us send this I1 towards left hand side. So we are going to get 1 plus 16 by 20 plus 8 by 20 into I1 is equal to 3 by 20 into V1. So I am multiplying and divide by 2, 2 plus 1, 3, in denominator will be 20 minus V2 by 10. So let us rearrange these equations here. So if you write, so 20 plus 24 divided by 20 I1 is equal to 3 by 20 V1 minus V2 by 10. So it is 44 by 20. When we send this one towards right, we get I1 equal to, so 20 by 44 into 3 by 20 V1 minus 20 by 44 into V2 by 10. So my 20 gets cancelled here, and here 10 1 by 10 puja. So we are going to have I1 equal to 3 by 44 V1 minus 2 by 44 V2. So if you observe from the previous slide, we got 3 by 44 and minus 1 by 22. So 3 by 44 here and minus 1 by 22, nothing but minus 2 by 44. So we got the same answer. Now let us see, apply this I1 and substitute this V3 in this equation also. So if you try to see, so we get I2 equal to V2 minus V3. V3 is nothing but V1 minus V1 divided by 10 plus V2 divided by 20. Right, we have substituted this V3 in this equation. So if you try to rearrange, we get I2 equal to, say, 2 V2 and we have V2, so 3 V2 by 20 minus V1 by 10 plus 8 by 10 I1. So we need to eliminate this I1 by using this particular equation. So if you try to substitute here, we get I2 equal to 3 by 20 V2 minus V1 by 10 plus 8 by 10 into 3 by 44 V1 minus 2 by 44 V2. So let us rearrange these equations. So it is 3 by 20 and we have plus 8 to just 6, plus into minus, we have minus, so 16 divided by 440 into V2, and we have here plus 8 3 is 24, 24 by 440 minus 1 by 10 V1. Now let us recompute this one. So let us multiply and divide by 22. So we are going to have 66 divided by 440 minus 16 by 440 V2 plus, let us multiply and divide by 44. So 24 by 440 minus 44 divided by 440 V1. So let us write this equation. So I2 equal to 24 minus 44 minus 20 by 440 V1 plus 66 minus 16, we are going to have 50 by 440 V2. So my I2 will be equal to minus 2 by 44 V1 plus 5 by 44 V2. So this will be my Y21 and this will be my Y22. So which we got similarly in the previous. So this is my Y11 and this will be my Y12. Okay. So if you try to compare, we got the same 3 by 44, 5 by 44, See here 3 by 44, we have 5 by 44, and y21 equal to minus 1 by 22, minus 1 by 22, and here minus 1 by 22. So whatever the method we have, we are going to get the same answer. Thank you. Now in the next class or in the next lecture, we shall see the ABCD parameters. Thank you.